Well, okay, so I'm James Ward. I'm a developer advocate at TypeSafe. And tonight's talk is going to be about Spt Web. It's a brand new thing that we've been working on. It's mostly been worked on for Play, but it's really generally applicable. So if you're not using Play, if you're doing anything related to client-side assets, client-side programming in your Scala apps, then this will be relevant to you. So that's what this is about tonight. Feel free to stop me at any point and ask questions. Oh, I have a question. Alexi, what time do you want me to wrap up?
Actually, I think I'm pretty flexible.
OK, so 10 o'clock is cool? All right. I guess if the beer starts coming in, then we can. OK. So we'll go for beers or something at some point.
Recording the screen capture?
Record. OK, it's recording. Yeah, so feel free to stop me at any point and ask questions. I'm going to be trying to write a bunch of code tonight, and we'll try to make this as interactive as possible. So let's start out with a couple slides, and then we'll get into some code. So Spt Web, it's this new tool, new set of tools. And really what it's about is creating some Spt plugins that allow us to have grunt-like functionality inside of our Spt builds. So we support the Node API and also webjars, and we'll talk more about what those are in a little bit. Ultimately, it's an asset pipeline, and then has a few other features that we'll see as well later. So what does that actually mean? There's a bunch of different parts of asset pipelines. There's parts of asset pipelines that do source linting, and this is all for client-side assets. So this whole thing, it's all about the stuff that runs in the browser. It's all about our JavaScript, our Coffeescript, our less, our Sass, all that whole side of our development. What's been happening, what we've seen is that a lot of people are using Play or Finagle or other Scala libraries to do their services, and then they use the JavaScript tools to do the client-side stuff. And that's fine if you want to go that route. That's going to work just fine. But what we want to do is have an option for people who want to have their whole toolchain on top of the JVM. And so the way that we've done this is we've created this set of asset pipelines. So first, there's source linting. So this is being able to lint our JavaScript, our Coffeescript, whatever. This is being able to take source files and create executables. So executable in the web world is obviously JavaScript. So we can take source files, whether that's JavaScript to JavaScript, or whether that's Coffeescript or TypeScript or Scala.js, whatever those things are, we're going to transform those into the executable that the web can actually run. Then there's on the other side, those are the source ones. There's asset pipeline tools that will take executables and then do some transformation to those executables. So one of those is being able to optimize the executables. Uglify is one of the tools that does this. So this takes our JavaScript and then turns it into a minified version of the JavaScript. That's an optimization, a post-compile optimization. There's fingerprinting. So we want to be able to have an efficient way to fingerprint our assets. And this can be, the way that this is usually, or the reason why this is usually used is that we want to fingerprint these assets so that we can have an e-tag header that is some value that's unique to that version of the asset. And we use that e-tag in both the HTTP header, but we also use it in the URL so that when we want to change the version of that thing, we now have a new URL to the new version of that thing. And that's important, because if you have the same URL, then you can't put far future expires on these things. And so really changing the URL is the primary way to be able to tell the browser, put this in your cache and never, ever, ever again ask for it. It's called far future expires. You basically tell the browser, like this content, it is never going to change. And so the way that you change it is to change the URL to it. So that's what we use asset fingerprinting for. Concatenation is another example of this, where I have 100 JavaScript files, and I don't want the browser to have to go make an HTTP request for every single one of those. Instead, I want to be able to combine all those together into one JavaScript file, or maybe a couple JavaScript files, so that the browser only has to make one request that's going to take longer, but it's going to ultimately take less time because there's a limit to how many concurrent requests the browser can make. So that's concatenation. So that's the job of the asset pipeline, is to do that. And then not really part of the asset pipeline, but something that's part of this toolchain is testing as well. And with testing, we're able to actually, in Spt, run tests in our JavaScript environment. So actually execute JavaScript tests just like we're executing our Java or Scala tests as well. So those are the primary things that the asset pipeline is doing for us and what we're going to cover tonight. Before we get into the details of how we actually do that with Spt Web, any questions about what an asset pipeline is and what it's doing? OK. So Spt Web, what it is, it's an asset pipeline on top of Spt. Play has had an asset pipeline in it from the beginning, I think. And the problem with it is that it wasn't very flexible. It was hard-coded into Play, and it actually used the compilers that it used, the tools that it used were actually like forked versions of the less compiler that everyone uses, and forked versions of the Coffeescript compiler, and forked versions of the Closure compiler. And so Play was maintaining all this stuff. And some of you have probably had the experience in Play where you try to use Play's asset pipeline to compile Bootstrap, is the one that we've heard a lot of people complain about. And the problem with that is that the less compiler has evolved ahead of what Play has done with its less compiler. And so most of the time, Bootstrap is being compiled with a newer version of the less compiler than what Play has in it. And so Bootstrap from less source won't compile in Play. And so to address that, that's one of the things that we created Spt Web for, was to allow you to have a lot more control over this asset pipeline, not hard code things into Play, but make this a lot more pluggable, and then also make it something that's usable outside of Play. So Spt Web, even though this is going to be, it's going to replace the old asset pipeline in Play 2.3, this is usable totally outside of Play. There is no dependencies on Play from Spt Web. So it also benefits from some of just the foundational features of Spt. Spt has really great incremental support, has really great parallel support. And so Spt Web just inherits those traits automatically. So that means Grunt is actually single-threaded. Spt Web is actually multi-threaded by default because Spt is multi-threaded and can run things in parallel. So we can actually compile your Coffeescript and your less at the same time now in Spt Web. So that's a nice feature of being built on top of Spt. Something that's actually really important to this is that you can choose the back end that you actually want to run these compilers on, these asset pipeline pieces on. So you can either choose to use the node native stuff. So if you're using less, you can choose to use the native less C that's on your system if you choose to install that through npm. You can choose to go that route. The default route is actually to use Node on the JVM. So there's actually an implementation of Node on the JVM called Trireme. And so we actually run Node on a implementation of the Node API on the JVM. So that means we run the actual less compiler and the actual Coffeescript compiler on the JVM through Rhino now, but we'll run it on Nashorn in Java 8 as well. But this allows you so that you don't have to install these additional dependencies on your system in order to be able to use this asset pipeline. And then you can choose if you want to use the native one or the JVM one. Today on Rhino, the Trireme one is probably going to be a little bit slower in terms of a single compile than the native one, because it's running through Rhino, and Rhino is interpreted and pretty slow. So that's one of the downsides. But if you want to have better compile performance on a single file, then switch it over to the Node native ones, and you're good. Where this actually becomes a really big deal for me is we have, for typesafe.com, it's of course a Play application, and we have asset compilers and all sorts of stuff. We were using a Node native compiler to compile our CSS. We were using Stylus. And the problem with that is that every time we stood up a new CI server, we'd have to then install the Stylus executables and the Node toolchain on those servers. Obviously, it's not a huge pain, but definitely was something that wasn't real fun. But then we also had to do that on Heroku and figure out a way to do that on Heroku as well, because Heroku, you kind of have to tell it which environment you want. Do you want the Node environment, or do you want the Java environment? So just having to having a full toolchain on the JVM definitely makes CI and deployment a whole lot simpler. So that's one of the reasons why we wanted to be able to provide the option of either running on the JVM or with the native libraries. So then one of the other benefits of Spt Web is that we use a project called webjars to define our dependencies on all of our asset compilers. Webjars, let me show it to you real quick. So webjars, and sorry that I'm on Windows. I rebooted so I can get some screen capture here because I'm usually on Linux, and Linux doesn't have great screen capture. So I'm on Windows, but I think everything should work okay. We'll find out. So webjars is, what it does is it packages up public JavaScript and CSS libraries into jar files and puts them in Maven Central. So now that we can depend on these client-side libraries just like we depend on our server-side libraries. So if we want to use less, we'll see that there's actually two different less ones here. One is, there's actually two different distributions of less. One is for the browser and one is for Node. So one's written against the browser API, one's written against the Node API. So we actually have two different webjars here for less. But this file, let's actually go look inside of it. This has in it the less.js. And so now, not with this one, with the other one, but we can actually now run that JavaScript on the JVM through Trireme, through Rhino, and run it on the JVM. Or you can use the native lessee if you want as well. But we can actually take this exact JavaScript file. I can specify a dependency on less version 1.7.0, and now I use that JavaScript file that came straight from the less providers and uses that as the asset compiler. And what that means is that this is just a standard dependency in my project. So if play ships with less 1.7.0 and I want to upgrade to 1.7.1, all I have to do is override that dependency in my project, and now I'm able to upgrade the version of less that my asset compiler is using outside of a release of play. And so that provides a whole lot better mechanism for managing this kind of stuff than what's currently in play. So webjars, you can also use these for the client side as well, and we'll see that a little bit later. But in the context of Spt Web, we use it for the actual compilers. All of the compilers for all the asset compilers today are being written in JavaScript because they're being written by the web folks. And so that's why we need this layer to be able to actually, and they're being written against the Node API. So that's why we need this layer to be able to actually execute JavaScript on the JVM if we don't want people to have to install additional tools. So yeah, so that's really the core of what Spt Web is about. Any questions about that stuff before we go on? Yeah.
I have a question about compatibility. So in terms of performance, you said that native is faster and single thread. What about compatibility across these implementations?
Compatibility should be the exact same because we're using Trireme, which is a Node implementation on the JVM, and they actually have a compatibility chart for the APIs that they've implemented and tested in Node, and I think they're getting pretty close to like 100% compatibility with implementing the Node APIs. So we haven't seen any issues there yet. So we're compatible there, and then we're fully compatible because we're using the same source for all the compilers that the Node versions use. So that less.js, or it's actually lessc.js, that JavaScript, we're running that same exact JavaScript for Spt Web as Node runs for running the less compiler when it runs through Node. So it's the same exact source code, and that's really important because we don't want to like get into the game of like trying to write a less compiler in Scala. Like all this stuff is being done in JavaScript. Let's just embrace it, use it as libraries, and so as long as that Node implementation works, then this all works. And if it doesn't work, switch over to the native one, and you're OK. And it's really just an Spt toggle to turn it from our implementation on Trireme over to Node. So it's just a build setting. Yeah, good question. Other questions? OK, so that's the basics of Spt Web. So today, where we're at with Spt Web is we've just released Milestone 2A is the latest versions of all these different Spt Web plugins. And so these are all just standard Spt plugins. You can add them into any Spt project. And we've released, so 1.0.0 M2A is the current version. Play 2.3 M1, milestone 1, was just released a couple days ago, and that brought these into a release of Play. So if you want to try this out, I'll show you an easy way to get started, but Play 2.3 will have all these included, and you can try them out now on any SPT project or with Play 2.3. So the ones that we have there today are first JS Hint. So we use JS Hint as a linting tool for JavaScript. There's Coffeescript support. There's less support. Digest. The digest is what gives us that the E tag creates actually an MD5 file for every asset, and I'll show you that in a little bit. Gzip does a gzip on all of our assets. Mocha, this isn't really an asset compiler. What it does is it's the plugin for SPT that runs our JavaScript tests as part of our SPT tests. So that's SPT Mocha. Mocha is a JavaScript testing framework. And then RJS is abbreviation for require.js. So require.js is what now gives us concatenation and uglification, the minification, and then the ability to specify client-side dependencies and have those managed on the browser for us through require.js. So those are the current ones that we've been working on. One of the really great things about the whole Spt Web infrastructure is that it's now super, super easy to create your own asset compiler. It's really a few lines of code, and you can create your own asset compiler. You know, we need to create one for typesafe.com for Stylus, and it's going to be super easy once we do that. It's really because we're just using the Stylus asset compiler that's already out there and putting a little Spt wrapper around it. So the community definitely welcome to work on other asset compilers. So there's some other ones that we're working on, the community is working on. One is a standalone uglify one, so we want to be able to, outside of require.js, do the minification. Scala.js is one of the exciting ones. We want to, as part of this asset pipeline, be able to compile Scala code through Scala.js into JavaScript, Sass, and Stylus, or some others. And there's tons of other options out there for what people could do for asset compilers. So that's where we're at today. And before I show that to you, any questions about that or comments or other ones you need? Yeah?
I tried playing this past weekend, trying to use it in Play 2.2.
Yeah.
I didn't have any luck.
It should work with Play 2.2. What I think you actually need to do is turn off all of the built-in asset compilers in Play 2.2. So there's some parameters that aren't well documented that you can turn off the existing ones, and then it should work. If that doesn't help, post a message on Play Framework, and Christopher Hunt, the primary developer behind this, can help you out with that. Yeah. Yeah, but it should definitely work with Play 2.2. It should work. The one trick to this whole thing is it does require a new version of SPT. That may have been the problem, but so it's SPT 0.13.5 M2 or something ridiculous like that. So it's a new version of SPT.
That should work with webjars as well?
Yep. Yeah, and I'll show you some webjars and stuff later. Yeah. Cool. Great. Other questions about any of this so far? OK. Let's see. Mention that. All right. So let's actually create a new app and add Spt Web to it. So to do that, I'm going to use Activator. We just released Activator 1.1.1. So that's the newest release of Activator. Activator you may have seen in a recent announcement about Play. Activator is going to become the primary distribution for Play in the future. So what Activator is it's an Spt Launcher, just like the Play command was an Spt Launcher, and Spt has an Spt Launcher. So we have 3 Spt Launchers. We're trying to consolidate that down into now 2 Spt Launchers, so Activator and the Spt Launcher, which Activator is an Spt Launcher. So there's Activator as an Spt Launcher, which allows you to, in Activator, you can launch Spt and do Spt tasks just like normal Spt. And then you can also launch the UI for Activator. So there's a UI mode and a CLI mode. If you don't want to use the UI, that's cool. You can just use the CLI. So we have people that prefer both. Up to you which one you want to use. So I'm going to launch it first into UI mode. And so I'll just run Activator. And then I'll create a new project in Activator. So I created a new template. Activator has a bunch of templates that you can get started with. And let's see how good our search is. There it is. Cool. So I created a Hello Play Framework 2.3 Scala one. And so I'm going to use that template to start with here. So this one just has all the pieces already set up, all the Spt Web pieces. So it's going to take a minute to get that set up. Oh, and I was doing this on Linux before, so now I'm going to have to download some dependencies. So it's going to take a little while. So while that's going, let's go back. I had a nice primed Ivy cache when I was on Linux, but not anymore. So to set up Spt Web, the first thing we need to do is add a plugin to our Spt build. So each of those Spt Web plugins that I mentioned, each of those you have to add independently. And I don't know if we're creating like a wrapper one around those or not, or if you're always going to have to add them independently. Not sure what we'll do in play with that. But outside of play, you'll certainly have to add each of them that you want. So if you want to add the Spt Coffeescript one, then replace blah with Coffeescript and put it in your project and then plugins.spt file. So there's a new feature in Spt 0.13.5, which is currently in milestone 2, that we're taking advantage of in Spt Web, and it's called auto plugins. And auto plugins are a cool way where we don't have to bring in all these settings and have a bunch of stuff in our code to use an Spt plugin anymore. And it's a really nice new feature in Spt, so we're taking advantage of that in Spt Web to make it easier to set these up. So really all that you have to do to enable one of these plugins is add it to your project and then plugins.spt, and that's it. And then if you want to override some parameters, you can, but you don't have to. Let's see where our build is at. Still downloading dependencies. Good thing. Oh, now we're loading project. Good. There's fast internet connection here. So once that's done, so we in Activator, you can download Activator in 2 different ways. You can download, or actually 3 different ways. You can download Activator as a full distribution, which includes a bunch of dependencies and a primed Ivy cache. Right now, those dependencies are like Play 2.2.1 and Spt 0.13.0 and Scala 2.10.1 or something like that. So a little bit older versions of some of those dependencies. But so if you download the full distribution of Activator, which is like 250 megs, then you get a primed cache with all those. I'm using newer versions of things, so my primed cache is not being used for any of this, so now I have to download the whole internet. So there's also, in this case, what you should do, if you don't want any of those old dependencies, you don't want that primed cache, or it's not useful to you, then download the mini distribution of Activator. It's a meg, and then that after that download downloads all of your dependencies after you start it up. So 2 different ways. And then another way to do it is you can go to a template and download what's called a template bundle. And a template bundle is the template and the 1 meg Activator launcher. So those are the different ways to do it. Again, in that way, it's going to have to download all the dependencies from Maven Central. Yeah.
Just another question on this. So I'm used to just using Spt Launcher,
yep.
And there is a nice wrapper called Spt Extras on GitHub, which lets you specify the Spt version.
Yep.
So what kind of confuses me with Activator is that you're kind of like a dumb user downloading something into your home directory,
yeah.
And suddenly there are multiple versions of the Activator. So let's say I already have an Activator and all the version. What should I do if I want to use a new one? Should I just discard the old one? Is there a way to manage multiple installations? What's the right way to do it?
Yeah, so there's a couple different things there. One is the actual Spt version. If you have a sufficiently new enough version of an Spt launcher, it actually will download the version of Spt that's specified by the project. So that's been the case since like the, I don't know, 0.12 something launcher, is it actually looks at your project build.properties and then downloads that version of Spt to use. So you shouldn't have to have multiple versions. You shouldn't have to have the actual Spt launcher for the version of Spt that you're actually using. Those two can be decoupled. And so that's how Activator works as well, is that right now I'm using Activator Launcher 1.1.1, and when I launched it, you saw that it started pulling down Spt 0.13.5 M2 or whatever. So it was able to know, like, hey, I don't have the right version of Spt. I'm going to go download that version of Spt and then bootstrap into that version of Spt.
But in terms of Activator itself,
yeah, so then for Activator itself, so that's the other aspect, is the Activator launcher, it's really just the Spt launcher. So that's, you can run Spt commands based, and that's wrapping the Spt version that your project actually is. But then for the UI of Activator, we actually now, I think since 1.0.7, we started auto upgrading the UI part of Activator. So if you have Activator 1.0.7 and you launch the UI, it will actually go check to see is there a new version of the UI available, and if so, then it will pull the new UI down, which is just some dependencies, and pull those into your IV cache, and then launch the UI for the latest version of Activator. So that's been the case since I think 1.0.7. So we want to make it so you're not always having to re-download and upgrade these things. So really just that launcher piece, you should have to upgrade very rarely, unless we screw things up, which we have. So there have been bugs that we fixed in the launcher itself. The most recent bugs around this have been on Windows and have been related to proxies and those sorts of things. So for most users, they shouldn't have to upgrade the launcher very often. Does that answer that? Okay, cool. Let's see how our build is going. Still loading project. Come on. Let's try this again. 2.3. Actually, maybe it created it. Let's go check. Oh, here's a cool little feature of Activator. I'm going to stop the Activator that I launched here. You can, once you create a new app from a template with Activator, it copies the Activator launcher into that project. And I know it's probably bad in some ways, but I just put these files into the GitHub repo, to my Git repos, so that any user can just clone the Git repo and then launch Activator straight from there. They don't have to download or install anything. So, and then if you launch Activator from within a project directory, then it takes us to the Activator UI for that project instead of taking us to the home screen. So let's see how we're doing. Hopefully my demos don't fail. Compiling project definition. Spt lock. All right. We'll give this thing a minute and see if it works. If not, we'll just reboot into Linux. Any other questions while we're waiting for the Spt lock? We use IV underneath the covers today with Activator and Spt, and it's been a little bit of a source of pain in this world. Actually, you know what? I'll bet it's not actually waiting on that lock. I bet it's an erroneous lock. I would love for IV to go away, but it's going to be a lot of work to replace it. Let's try to delete our locks. Locking. I thought we were reactive. What is all this locking stuff, right? All right, let's try this one more time. If this doesn't work, we're going into Linux. Linux doesn't always work on a projector, but the IV cache usually works. Trade-offs, right? So we'll give that a minute. I guess while we're waiting for that, let's see. That's more Spt stuff. So, any other questions while we're waiting to see if this works? Okay. Any questions about Play? Play 2.3, other features in Play 2.3 while we're here? Yeah?
Is it going to be easy to upgrade from a project from 2.2 to 2.3?
Yeah, it should be. So things like the asset compiler should just work if you enable the new asset compiler. So that part should be pretty straightforward. We have some new APIs and some APIs that were deprecated in 2.2 and will be removed in 2.3. So the primary API change is around simple result. So we created this intermediary thing called simple result, which we deprecated in 2.3, and simple result, or sorry, we deprecated in 2.2. In 2.3, it'll actually go away and be replaced by just result, or maybe it's maybe we're not doing the deletion yet, but so that's one API that will change. Is we're doing this transition from an old API to the new result API. So that's something that could change. There's a new actor for doing WebSocket communication that's pretty cool. So that's coming up. There's, what else is coming in 2.3? The asset compiler stuff has been a big one. There's been some changes in some of the Java APIs around Java 8 and better supporting lambdas. So if you're a Java developer, then those will be useful. If not, then that's okay. So yeah, so those are the primary changes that I can think of. Is Java 8 and the client-side asset compiler stuff were really the two big focuses of 2.3. Yeah. Ooh, hey, we're in a project, finally. Cool. OK, so here's the Activator UI for my app that I just created. And I'm going to actually open this up in IntelliJ. Activator does have a little web-based code editor. I don't ever use it. I use IntelliJ. So I'm going to open this up here in IntelliJ. Activator does actually run the app. So we've got the code browser. We've got compile output, which is failing. Oh, no. Demo fail. We'll see if restart. Let's see if this works. If not, I'm going to reboot. So, so Activator, it'll run the project, run the compile, run the tests, and then we can also inspect the app. The inspect, what it does, it doesn't actually work yet in 2.3. It doesn't work on a milestone release, so it only works today on 2.1 and 2.2.1, 2.2.2. So inspect instruments our application so that all the requests that are coming into our application we can go in and look at and see what the request headers were and that sort of thing. And then we can also see information about our actors, what actors we have in our system, how many messages they're receiving, that sort of thing. So, but it won't work on this app because this app is a 2.3 app, and we're still resolving assets. We're going to give this one more chance to do the right thing, and then we're going to give up. Go to Linux. OK, so every template in Activator comes with a tutorial. So when you're in the UI, you can read through the tutorial, learn about the code. This particular tutorial I haven't actually written yet, so there's not a whole lot of information in this one. But there's some other ones that have a lot of really great information in the tutorial. So you can check out the tutorials, learn about the code, and that's good. Looks like we may be getting close to resolving artifacts we're resolving. Oh, I can go start looking at the code, though. Now, oh, Spt locks. Damn you. Oh, man. All right. We're going to free up that lock so that we can actually go look at some code here. Let's go see. Resolving artifacts. Hey, there we go. We're moving forward. Downloading the internet. OK, this is why we want primed Ivy caches before we do demos. Yeah, go ahead.
I have a question for you. How do you launch Spt on in your CI environment and on Heroku? Do you install it as a dependency ahead of time? Or?
So on Heroku, they have a build pack for Spt, and so the build pack has the Spt Launcher and knows how to get the Spt Launcher, and so they do that for you. On my CI system, there's two ways to do it. One is that you could install, I think Jenkins does have an Spt plugin, and so that brings in the Spt Launcher to Jenkins, and then you can just set it up to call the Spt Launcher. Or I haven't tried this, but you should be able to use the Activator Spt Launcher inside of Jenkins as well. I haven't tried to do it that way. I've always used the Spt plugin in Jenkins, but it should work either way. Yeah. Yeah. Oh, yay. Our project is finally open. All right. Cool. OK, so we got an open project. Next, we'll see if we can actually run it. And I'm going to change my font size real quick so we can actually see. Oh. It's on the bigger font. That's good. OK, now let's see if we can run this thing. Let's try one more time. We can start looking at code. OK, so let's go take a look first at my plugins.spt file here. So plugins.spt, this is where I define first the play plugin. So the play plugin is that Spt plugin. Poorly named, I guess, but that's the Spt plugin for play. And then we define all of the Spt Web plugins that I want to use. So you'll see the required.js, Coffeescript, less, JS Digest, Gzip, and Mocha. So those are the different plugins that I'm using. So now if we go to my main project build definition, we'll see that I have a few dependencies in here. One is on the webjars play library. We'll look at that in a minute. I've got a dependency on the Bootstrap library. I'm using Bootstrap for the UI in this app. And then I'm also specifying a dependency on the required.js dependency. And I may not have needed to do that. I think the Spt plugin may have actually brought that one in. So I may not have needed to do that. Then you'll see down here at the bottom of the file, this is where we bring in all the settings for a play project into this app. So if you're doing Java, then it would be play Java. If you're doing Scala, then play Scala. This replaces the play Java settings and play Scala settings that you usually have in your build.spt file. So in this also brings in the Spt Web settings. So if you're using Spt Web outside of play, then you actually won't add the plugin for play. You'll add the plugin for Spt Web. The play plugin here, the settings, that brings in also the Spt Web settings. So it wraps that. So that's our build settings. That's all that we need. Any questions about the Spt build settings? Okay.
I just have a question about the play in IDEA. I know that IDEA has some play plugin for itself. I wonder if that's useful, if that's actually interacting in any way with this.
Yeah, so the play plugin inside of IntelliJ, it doesn't do anything as far as I know with Spt or any of the resources or any of that stuff. Where that plugin helps is on the routes file, so it understands the route file syntax, it understands the Scala template syntax, so it understands the things that are specific to play, but it doesn't do the Spt stuff. What does the Spt stuff is the Scala plugin. So when you install the Scala plugin in IntelliJ, it knows what an Spt project is. You'll see that I opened up this Spt project without having to generate any project files. That's a fairly new feature in IntelliJ and the Scala plugin. So I can just go to any Spt project, open it up in IntelliJ. It pulls down my dependencies for IntelliJ or resolves them for me in IntelliJ and sets up all the project definitions for me. So that's part of the Scala plugin. So in this case, there's not anything special yet about the play plugin for what I'm doing. OK, so we've got any other questions about build definition stuff? OK, so that's our build definition. We'll show you, let's see, yep, it is 0.13.5 M2 is the Spt version that we're using. And let's go see if we're able to run this time. Oh, could just not work on Windows. We will try this a different way. Let's try the command line. All right, let's hope this works this time. OK, so that's our build definition. Let's go see now the routes file. Nothing real interesting here. If you're not familiar with webjars, we have a route to there so that we can get to our webjar assets. So this provides a way to get to like bootstrap.css and jQuery.js and those sorts of things. So that's our routes. Nothing real interesting in here. Our controller so far, nothing real interesting in our controller, and we're going to stay out of the controller stuff tonight. So let's go check out our views. So here's our main index page that we're using, and then that's calling main. So here's our main page. So let me show you how the webjars work. So in this case, what we're doing is we have a dependency on Bootstrap, And so I have a line here in my template where I'm saying, all right, give me a style sheet, and I'm going to use this WebJar assets controller. So that's the reverse route to the WebJar assets controller. And then I'm calling this WebJar assets.locate. The reason for that is that the actual path to bootstrap.min.css is actually has the WebJar ID, which in this case is Bootstrap, and it has the version of that library that I'm using. So it was like 2 or 3.1.1 or something like that. And then in a CSS directory inside of that, there's the bootstrap.min.css. So I'm using WebJar assets.locate to resolve the path to that thing. The reason why I want to preserve those URLs with the version numbers in them is that those version numbers essentially become the way that I can use far future expires on this content. So WebJars are set up to be able to be cached forever. So a WebJar asset, once the user loads that down onto their machine, then you can put a far future expires header on it, and the user should never have to pull that down again. So that's why we leave the version numbers into the WebJars, is so that we can get that behavior. But we don't want to hard code those version numbers here in our paths, so we use that locator to be able to get us the path. And WebJars recently added support for require.js, so I think maybe later we'll get into some require.js and WebJar stuff, but you can use WebJars with require.js, and then we also recently added support for CDN, for having all these on a public CDN, so you don't have to set up your own CDN for your WebJar assets. And it's really easy to toggle from pulling these assets from my local play app to pulling them from the CDN. So that's how we set that up. You'll see I'm loading in bootstrap.min.css and jQuery. And so that's my main app. Let's see if we were able to actually run this thing. No, we're still locked on the Ivy repository. Gotta love downloading the internet. Why?
It's like it's IntelliJ and your...
Yeah, they're like competing against each other, right? Oh man, Ivy caches. It was Maven caches before Ivy caches. Go away, lock file. Wish we could make Ivy reactive, right? All right, so let's start actually using some of the features here of Spt Web. So to start, let's start with the linter. So I'm going to create a JavaScript file, and we're going to have that go through the linter if we can get this app actually running. So let's create a new package here. So by default in play, all of our assets that go through the asset compiler go into app assets. And you can change that. It's just an SBT setting. If you're not in play, then it's source main assets is the main source directory for your client-side assets. So let's create a new file here, and this will be foo.js. And then this will just be our standard JavaScript source. Oh, and it's not going to be very exciting if we can't actually see it run. So I'm going to reboot into a working operating system with a good Ivy cache. And that's not going to be fun, but bear with me. Sorry, the video is going to be sacrificed for a working demo. But that's OK. So 1 second. Can't have a milestone product without a failed demo, right? All right, so we'll reboot that. So once we get this working, what we'll see is that we can write JavaScript code. And that JavaScript code, if we have added the Spt JS hint plugin to our project, then it will lint that JavaScript and tell us if there are any JavaScript errors. Super exciting. Good thing Linux boots in 6 seconds. Here we go. And let's go back to my project here. All right, I'm going to expect a whole lot of cheering if this app actually works this time. resolving dependencies, please, yay! Cheer! We have a working app. All right. Yay, thank you, Linux. Saves a day. Okay, let's go load this thing up here. And then we'll get going. Okay, let's go to my presentation. All right, and now IntelliJ, indexing, index faster. Okay, all right, here we go. Now let's go create a new file again, foo.js. And let's do some bad JavaScript. What's some bad JavaScript look like? Is that bad JavaScript? Let's try it out. Yay, okay, there's the linter. So the linter is telling me, hey, that's not valid JavaScript. And we see it in our browser just like we see all of the other errors that we see in a Play application. So we've got linting working. That's great. Let's go fix this and verify that everything recompiles. So I don't need a function. Let's just do alert. Oh, and I probably need a semicolon. Gosh, hate those semicolons, right? I hate writing semicolons in JavaScript now that I've been doing Scala. Didn't see my alert. Oh, I didn't import it. I didn't use it. So let's go actually put this thing in a file here. So let's go script, and then source equals, and then I'm going to use the reverse router. So routes.assets.at, and I'm going to tell it to load foo.js, right? So save that and reload. And if our browser lets us display alert messages, there we go. Cool. OK. So now our JavaScript is obviously working. It's in the page. So that's the JS linter. Not super exciting or complex, but definitely if you're working on a large code base of JavaScript, essential to have that kind of quality assurance tools. OK, so that's that. Questions about the linter before we go on? OK. Let's go on to the next one. So there's linter. So the next one is a Coffeescript one. So as you probably guessed, to add Coffeescript, I've already added the plugin to this project. So now I can just come in here and add in a index.coffee file. And let's do some jQuery here, right? And log something out using jQuery on ready function call there. And let's go back to our template. And now let's use index.js. And hit reload. And if we go inspect, there we see our ASDF that we just outputted from Coffeescript. So now that Coffeescript is now part of that asset compilation process, just like the rest of our code. So let's go back here and let's make a, what's invalid Coffeescript? Is that, no, @ signs are valid. Percent signs? What's invalid? That's valid. There we go. OK, so now just like with the linter, just like with our backend code, we see the errors there in the browser. So that's the Coffeescript compiler. One thing that is different about Play 2, 3, and Spt Web in this respect is that I don't right now have a minified version of this file because in order to do the minification, we need to use the require.js plugin. And I could do that. I could set up require.js. We'll get there. But, and we don't yet have a standalone uglify Spt Web plugin, but we will. So, so I don't get the minified version of this file until I run it through require.js right now. So that doesn't exist yet. So that's a Coffeescript plugin. Questions about that? OK, pretty easy. OK, so next up, let's make sure we're still working here. Okay, good. So next up is Spt less. So super simple, right? We can go in and create. One thing you'll notice, this is different from play before this, is that I don't have to actually put these files into a JavaScript package or a style sheets package. It looks for, the asset compiler by default looks for anything in the assets directory that has the extension that we're expecting. So it doesn't have to be in the subdirectory format that we required in play before 2.3. So let's create our index.less, and let's add body tag, background color. I'm very creative with my color schemes and changes. Let's go use that style sheet here. So assets at, and then what I call it, index.css, and I need some quotes. Does that look right? Oh, wrong. What did I do wrong? Index.css, there it is. Background color. Oh, body, background color. That's right. Rich, why isn't my CSS working? Was that?
4 zeros.
Oh, thank you. Why didn't the less compiler tell me that? Nice catch. I owe whoever that was a beer. That was a good one. There we go. Now we see a red background. Cool. So anyways, that's the less compiler. It should be catching those color mistakes, right? What kind of compiler is that? So that's the less compiler. Any questions about the less compiler? Okay, pretty straightforward. Okay, Spt Digest. So this is the one that's creating our MD5. We can also create, I think, SHA-1 files that contain the actual MD5 or SHA-1 signature of the file. So the default is just MD5, and then you can enable SHA-1 or disable MD5 if you want. The way that we see this is to, right now, if we look in where these files are going, so if we look in, this is in target web is where all of our assets are being managed. This is like the classes, managed classes directory for my assets. And so you'll see that right now there's just basically the standard stuff there. You'll see there's also the WebJar contents. Sbt Web extracts out the WebJar contents so that I can use those as well. But you'll see that there's no MD5s, there's no gzipping, there's none of that yet. And we actually only run those tasks when you go into a production mode or a production distribution. So the way that we can do that is to run Activator, and then we could run start, or we could run stage, or we could run dist are the 3 tasks that will do that. Let's run, let's just run stage so we can see those files. So stage, what stage does with play is it creates a stage distribution. So that's everything that my application needs to run somewhere else. It's all my dependencies, it's the start scripts, and it's my application all compiled up and all my assets compiled up. And so it creates that. And so if we look into target web, actually let's go do that find again. Now we'll see that now that the digest plugin now ran on all those files, and we can go see now that here is the MD5 signature for index.css. So we write this into this separate file, and today we don't actually use that for anything. But what we can use it for is we can use it to change the URLs for our static assets is one way that we could use that. And the static asset controller in play will use these to get out the MD5 signatures for the files. So that's one way that we'll use it. You could use this as part of your build process as well. People do different things like build app manifest files and those sorts of things based on these. So there's a lot of different things that we can do now that we have all these signatures there. So that's, yeah, question?
Question, like one of the obvious uses for this would be to see that your site is not defaced, that all the assets are still at the published version. Is there anything in play you can use to basically enforce that the assets still have their signature?
You know, I don't think there's anything in play. What we could build on top of this is the web has a manifest file, and a manifest file I think can do what you're talking about. I don't know a whole lot of details on it. Maybe somebody knows more. But I think that with an app manifest file, we could generate the manifest file and then do verification based on that, possibly. I don't think in the browser there's any way to, maybe there is some way to actually pull down an asset and then do the MD5 on the client side of that asset and then compare that against this file. So there might be some way to do that. Interesting to explore. Does anybody know anything else about manifest files and what they can do? I don't know a whole lot about them. OK, so that's the digest plugin. Any questions on that? OK, next up, there's the Gzip one, and that one I've added it to my project, and you'll see that, yep, there are the Gzip file versions of all these files as well. So one of the main purposes of this is that services like CloudFront will, if you have the .gz version of your file, then it'll use that as your Gzip version of that static asset. So you could actually take all these files, upload them up to S3, put CloudFront in front of them, and then have CloudFront serving both the non-Gzip and Gzip versions of those files based on what's been generated here. Yeah?
So if you do that using CloudFront or some other CDN, is there any like kind of Cdml integration either at the at whichever part of the tier is appropriate here, or is that kind of left as an exercise to the reader?
That's left as an exercise to the reader. We could easily write an Spt plugin that when we do like a play dist would take your assets and upload them up to S3, something like that. Let me show you how we actually do this for typesafe.com, because it's the way that I prefer to set this up, but it's certainly not the only way. So if we, why do we have so many errors on typesafe.com, Rich? Rich is our web developer on typesafe.com. Here my whole demo is going to fail because we've got all these, oh, it's all the head requests. Interesting. OK, so what we do on typesafe.com is when I'm developing typesafe.com, when Rich and I are developing typesafe.com locally, we're using webjars, and all of our static assets are being served out of the local play application. So my jQuery, all of my images, everything is being served out of my local play application. And then when we deploy this onto our production server, there's a setting there that says don't get these static assets from typesafe.com. Instead, get them from our CDN. And so if we look at jQuery here, the URL to jQuery is our CDN, which is on CloudFront. And then it's the same URL, the rest of it is the same URL as what's available on typesafe.com. So if I copy this URL here, I can get to that resource, right? But in this case, it's actually pulling that resource from the CDN. So it's pulling that from CloudFront. What I've set up is, sorry, go ahead.
Is the recommendation that you configure your CDN to fall back appropriately?
So what I've set up the CDN in this case to do is the CDN, the CloudFront, it uses my server as an origin server. So it uses typesafe.com as an origin server. So when a request comes into this URL to CloudFront/webjars/jQuery/whatever, if it doesn't have that asset on the CDN, then it goes to typesafe.com to get that asset, and typesafe.com has the far future expires headers, it has the E tag, it has all the right information, it has the Gzip encoding, it has everything that's needed for CloudFront. And then after that first request, then CloudFront then caches that asset on the CDN, and so then there's not going to be any additional requests to get that asset from typesafe.com. So that's the way that I prefer to do that, because there's no additional deployment step. There's no like copying files to S3. That's the simplicity of this model is why I chose that. But there's obviously a lot of different ways to do this sort of thing. Other questions about that? OK. Oh, yeah, go ahead.
I was going to ask you if you wanted to use a CDN, or let's say a public version of jQuery.
Yes.
A lot of people use jQuery. Would you be able to override the CDN to not point at your, let's say, CloudFront instance, so it
Yep. You definitely could. Today, so I don't do that here. There's some trade-offs to that. One is you get a whole lot better caching if you're using the one that everybody else is using. But the downside to that is that then I don't feel like I don't have full control over my static assets. So in this case, I chose not to do it that way. You definitely could change these URLs out to the public CDNs if you wanted to.
That's on a URL by URL basis, not global.
It would be on a URL by URL basis. So when we set up CDN support for webjars like this one, which I'm not using the webjar CDN. There's a different, it's the JS deliver is the CDN for webjars. So we did set up a CDN for webjars that has all the webjars, all the versions on a public CDN. And we did that instead of using the like jQuery public CDN because we can't guarantee 100% compatibility of the webjar, what the webjars have in them and what the public CDNs have in them. So as a very practical example to this is jQuery. So you'll see jQuery there, it doesn't have the version number in the file, it has it in the directory name. And the way that jQuery distributes their files is with the version in the file name, not in a directory name or anything. So the CDNs all have a version number in the file name, which would be okay. We could work around that. But the problem with it is that jQuery, because they hardcode the version numbers in the file names, they also have to hardcode the version numbers actually inside the files because of source maps. Source maps create a relationship between two different files. And because they're using the version name in the file name, now they have to hardcode that version number into the actual file. So for webjars, we actually go into the jQuery files and we actually rip out the version numbers out of the files so that those source map links still work. But that means that this jQuery.min.js is actually not the same file as the one that's on the public CDN. So because in webjars we can't guarantee that there's always going to be a correlation between what we distribute through webjars and what the public CDNs have, we set up our own public CDN, which means that we're not going to get as good of caching as if you're using the public CDNs, but there's going to be trade-offs. So, yeah. Okay, so that's a short deviation onto CDNs and that fun stuff. Okay, so that's how we do it on typesafe.com. So gzip. Now let's go on to Mocha. So Mocha is the testing library. Before I go on, any other questions about CDNs before we go on? Okay. So Mocha is a testing library for JavaScript that is now part of Spt Web. So to use it, we can just go create here a new test. And what we do is we create these into an assets directory. So in test, and then we'll create a new package called assets. And then I'm going to create a new file here. And these need to be named either ending with spec.js or test.js. That's a setting in Spt that you can change, but that's the default. So I'm going to name this foospec.js. And then let's just copy and paste this stuff here. Okay. So now I've got my test, which isn't very exciting. I'm just testing that 1 + 1 = 2. And now let's go run that test. So I'm going to run Activator test. That just runs the Spt test. And I've got some Scala tests in there. And then I've got the JavaScript test. Oh, and it's even going to lint the JavaScript for me. So that's great. So it linted it. And then you'll see that it ran my JavaScript test. And one of my Scala tests is now failing. So ignore that. But here it said that was the test. Foo should correctly add numbers, and it passed. So now alongside my Scala or Java tests, I see also the output of my JavaScript tests. And this is a pretty simple example, but you can also use require.js as part of this as well, so that if you want to inject basically different dependencies for your tests, then in your actual web app, you can do that through require.js. You can use mocking tools. There's some pretty powerful parts in here that are really just powered through Mocha. We just use Mocha and execute these tests through Mocha and report back the results through the standard Spt test runner. Yeah, good. Unless there's a wrapper, if there's some way to use Jasmine from Mocha, then no. I know that it was something that we were looking into, and so it may be another Spt Web plugin, or it could be that we could do it through the Mocha one. I'm not sure. There is a whole different way to do this where you can actually run, there's some wrappers in Scala, so you can actually create Scala wrappers around Jasmine tests using like HTML unit or Selenium WebDriver. So you could use those as well for Jasmine. I know people are doing that today, but this actually runs these through the JavaScript runners, which are, I think, all based on the Node API in this case. So. So I don't know if there's a connection between Jasmine and Mocha or not, but certainly if there's not, we could create an Spt Web plugin to do that. Yeah. Other questions about Spt Mocha? Okay. All right, so that's testing. Let's go to require.js. So with require.js, let's go set this up. So I'm going to copy some stuff in here. And let's go create a new JavaScript file. This will be main.js. And there is my main application. So I'm setting up this require configuration. You'll see that I'm setting up some path information for my libraries, for my JavaScript libraries. So I'm saying jQuery, the path to you is /lib jQuery. And that's actually the being extracted from the webjar. So this is now taking the contents of the jQuery webjar, which I don't think I explicitly have, or do I have a dependency on it? Let's go check out my build.spt. Yeah, so I don't actually have an explicit dependency on jQuery, the jQuery webjar, but it's a transitive dependency of Bootstrap. So I didn't have to specify the dependency on the jQuery webjar, but it brought it in as a transitive dependency. So what Spt Web is doing is it's actually pulling all of the contents of my webjars out into basically an area that becomes available through these paths. And we could actually test that out and make sure that it works. So if we go to /assets/lib/jQuery/jQuery.js, then there we see jQuery. So that's automatically is now there because it was extracted out of the webjar. So that's what that path is doing, is just saying that when I have a dependency on jQuery, that's where to get it. Same thing for Bootstrap. And then the shim configuration exports, I'm exporting $sign for jQuery, and then I'm setting up a dependency on jQuery for Bootstrap. So that's what the shim is for. This information is already part of the webjars, and one of the things that we're trying to figure out next is can we use this information that's already in webjars instead of having to define it here. So we haven't figured that piece out yet, but hopefully in a future milestone. So then in require.js, I'm saying, all right, require Bootstrap, which will bring in Bootstrap, and we'll bring in jQuery, because the Bootstrap JavaScript depends on the jQuery JavaScript. And then I'm displaying a modal dialog. And now let's go try it out here. I'm going to now load in. Actually, that's not how I load it in. We have to do this a little bit differently. So let me go copy and paste that. So with require.js, if you're not familiar with it, we need to load the require.js library. So I'm actually still using the webjar to load in the require.js JavaScript. And then I set a property on my script tag data main, and I tell it where to find the main application to run. And so this is once require.js is loaded, then it's going to load up the main.js in this case. So and that should be good. So let's go try it out here and make sure that require.js assets main, that should be good. Where's my modal dialog? No errors. Gotta love JavaScript. Anyone see my problem? Oh, yeah, that's what I forgot. Thank you. Yeah, where is that my modal thing? It doesn't exist. I forgot some important information from my slides. I have that somewhere over here. That's in main. Nope, index. There it is. Okay, let's copy that guy. There's my modal. All right, let's try this again. Hey, there's my modal. So when the page loads, it's using now the bootstrap modal. So that set up all the dependency loading now based on required.js, which you may have noticed that my index page, it's actually still bringing in, or my main page, it's still bringing in jQuery manually. I should actually be able to now drop that out of there because required.js should be now loading that for me. So let's go try that out. So still working there. If we load up the inspect window, we should see that there, when we load required.js, and then we load jQuery, and then we load bootstrap. So required.js is managing that transitive dependency for me. Yeah?
Yeah, can we get that to optimize that into one file?
Yeah, that's where we're going next. So, other questions before we go there? Yeah?
You having a little trouble following what's new in the Spt Web versus what was in play
Yep.
that was specific to play? Can you just mention something?
Yeah, good question. So what's new and different? So the Digest plugin is new. The Gzip plugin is new. And then the whole way that we run plugins is new. So that's not going to be something that you really see unless you had incompatibility issues between how we were running those asset compilers before and how we're going to run them now. So the way that we're running them now is just using the standard JavaScript asset compilers. So there should be no difference in how you do that. And then the upgradability, the independent upgradability of the actual compilers, that's a huge difference as well. To upgrade the less compiler, the actual less compiler in play before this was pretty much impossible, and now it's very easy. It's just a dependency that you specify. So those are the primary differences from the what features do I get, what new features do I get. The Digest and the Gzip are really some of the only real new features. But what we're hoping is that this opens up a whole new world of asset compilers that are built on top of this. And so we're not going to have all the hack tower stuff that we had before with asset compilers.
What about running tests? Could you run?
Oh yeah, so Mocha, the Spt Mocha one, that's also totally new. We didn't have anything like that before. Also things like generating the source maps, that's something that we weren't doing before. That now just works out of the box. There's all sorts of new parameters. So what we try to do for all of these is we take all the parameters that the downstream compiler takes, and we now move those out into Spt settings. So all of the compiler parameters that are available on the downstream tools should be available now as Spt compile options as well. So a whole lot more flexibility in the different parameters that you could specify for the compilers. But yeah, that's the main stuff. Yeah. Cool, so are there any other questions before we do the concatenation on this thing? Okay, before we do concatenation, let's do something slightly more interesting here. So we've got our foo.js. Let's tell our main.js here to load also in that foo. So that'll be /foo. And let's move this thing. Let's leave it there for now. Actually, I think it's going to probably optimize. No, let's try it without. Let's make sure we still work. Okay, we still work. That's good. So now, on this project, let's run Activator stage, and this will do now the require concatenation and minification on that main.js. So it'll take a second to run that, but then what we should see, if we go into target web, and somewhere in here, I think it's under RJS app, appdir, and then main.js. Nope, that's not the right one. Somewhere in here it's going to be, or not. Let's try this. Oh, you know what? I think there's some bug and I have to run a clean before. Oh, actually, you know what happened? I think it actually compiled over my files. I compiled and then it compiled over them. So don't run a run while you're doing a stage or else you're going to overwrite your new main.js. Let's try this one more time here. So this is a problem that I think we need to address is right now we overwrite main.js based on whether you're doing a run or whether you're doing a stage. And I think instead we need to generate a different file rather than overwrite them. So that's a problem with 1.0.0 M2A that I think we need to resolve. I just reported that one to the team, so hopefully we get that fixed soon. But let's see if we get our minified version. Looks like we're in single-threaded JavaScript land because you can see, maybe you can't see, but at the bottom, I've pegged one CPU. So one CPU is pegged on probably require.js running on this thing. So this might be a good place to switch over to the native Node one rather than the one based on Rhino, but still trying. A little slow. Chugga, chugga. Any questions about this one? No, this is using the Rhino trireme one. So at this point, it's single-threaded, and it's single-threaded running on Rhino on the JVM. We are working on Nashorn support as well. So Nashorn is the new JavaScript engine in JDK 8, which is a whole lot faster than Rhino. And so when we can run this on Nashorn, it should be near the same performance as the native Node ones. But until then, it's going to not be as fast. OK, great. So we're done generating that. Let's go check out target web. What did I say? RJS, after, and then main.js. No, that's not the right one. Is it? Somewhere in here is a main.js, and there should be a minified one too. Or not. Uh-oh, something broken. Let's look at all these. Ah, there it is. I don't know why it's in a weird directory, but OK. So this is now the concatenated and minified version. I don't know why it didn't do the min extension, but that's the concatenated and minified version of that app. So we should see in there the contents of foo, unless it optimized it out, which is possible. But alert ASDF, do we see an alert ASDF in there? It may have optimized that thing out. Oh, there it is. Thank you. Sweet. So yeah, so there it did concatenate the files together and minify. So the other thing that you'll see in there is that the paths, so by default, what the require.js plugin is doing when it creates the concatenated minified version, it's also changing my paths. And you'll see that the new path for jQuery is now using the public CDN for jQuery with the versioned URL for that file in it. And there's some parameter where if we wanted to take jQuery.js and take bootstrap.js and we wanted to merge those into one concatenated file, I think there's a parameter to do that in require.js. But in this, I think the default, well, obviously the default is to not do that with these external pieces. And so instead, it changes the path to be the public CDN path for those, which isn't the public CDN. It's the webjars public CDN for those files. But they are versioned in the URL, so that means you can do the far future expires on these. Well, the CDN does that, and so you should never have to request these again. So there we go. So that's the require.js plugin. Questions about that? OK. I think that's it. So if you want to learn more about this stuff, all the projects are on GitHub under the Spt organization. So Spt Web is kind of the main entry point, and then there's different projects for all the different plugins. But I think all of them are linked to from the Spt Web project. And then the Play 2.3 migration guide, which is available on playframework.com. And then if we go to the docs and then select 2.3, I think we want 2.3 snapshot. There should be a migration guide here. And so you can learn a lot more about the Spt Web stuff and how it relates to Play in the migration guide there as well. So that's Spt Web. So any questions before we wrap up and go get a beer or something? Are we getting a beer, Alexi? Is that the plan?
Yeah.
Yes. OK, perfect. Sounds good. OK, any last questions about anything? Yeah.
Like, who would you say is the kind of like the most high-scale, web service that is based on Play specifically? Based on Play?
Good question. So Clout is a good example. Clout does, I think it was 10 billion transactions a day through like 8 Play servers or something. So that's a good one. LinkedIn has been in the process of basically standardizing on Play. They're in the process of changing over their homepage to Play. So that'll definitely be a big one. Walmart Canada is now a Play application. I'm sure they get a ton of traffic.
I know Netflix is quite active on Scala, so
yep.
Are they using Play?
They're not using Play as far as I know. They're using Akka and Scala, but haven't used Play as far as I know. Yeah. Yeah, so those are the examples that come to mind. Maybe others know of other ones, but yeah. Any other? Yeah, go ahead.
So part of the migration point is that you can use Spt Web outside of Play.
Yeah.
What do you lose, if anything, if you use it in some other web framework?
Nothing.
Like probably not much, right?
Yeah, yeah. It generates resources into a classes directory, and most Java web frameworks serve static assets out of the class path. So that works really well. You don't have to do it that way, but because they're already going into a managed classes directory for Spt, then super easy, like Play does, to serve assets out of the class path. So yeah, I know that people are already using Spray with Spt Web, so and I'm sure you could use Finagle and could use, if you can use the right version of Spt with Finagle, and you could use Scala Wrappers and whatever. So I'm sure that all of them would work with this as long as the Spt version compatibility works. Yeah. Yeah. Cool. And if you have any feedback on this stuff, post on the Play Framework list or email me or whatever.